What is software development methodology? As a verb, the software development methodology is an approach used by organizations and project teams to apply the software development methodology framework and technology. These software development approaches are: waterfall approach, a linear framework type; prototyping approach, an iterative framework type; incremental approach, a combination of linear and iterative framework type; spiral approach, a combination of linear and iterative framework type; rapid application development (RAD) approach, an iterative framework type; an extreme programming approach. The following are some of the software development methodologies.
Hi, this is me, News Today. In this fast-paced video, I want to show you why Scrum is so great, and how you can get started with Scrum in under 10 minutes. I'll cover all the core Scrum concepts like product backlogs, team roles, sprints, burndown charts, and more, so get ready to be bombarded with information. Let's say this is the product we want to build. For this product, we get all kinds of feature requests from users, customers, executives, or even other team members. In Scrum, the collection of all these features is called the product backlog. Another way to think of the product backlog is to think of it as a wish list of all the things that would make this product great. Once we have our wish list, or the product backlog, we need to start planning which specific features we're going to put into a particular release of our product. But we're getting ahead of ourselves. Let's back up a bit. To build this product, we need to have one or more people in our team who are going to play a variety of roles. First, we need her. She plays the role of product owner and helps make sure the right features make it into the product backlog, representing the users and customers of the product. She helps set the direction of the product. Then, we need this guy. He's the Scrum Master, and his job is to make sure the project is progressing smoothly and that every team member has the tools they need to get their job done. He sets up meetings, monitors the work being done, and facilitates release planning. He's essentially a project manager, but that's such a boring title, so we'll call him a Scrum Master to imply he knows some jiu-jitsu. And the rest of the team has similar roles to other development processes. These guys build the product, while these guys test it to make sure it works right. These guys use it and hopefully pay for it. And these guys generally get in the way, but it turns out you can't build many products without them. But let's get back to this, release planning. To plan and release, the team starts with this, the product backlog, and they identify the features they want to put into this release. These features then become part of the release backlog. The team then prioritizes the features and estimates the amount of work involved for each feature, providing a rough idea of the total amount of work involved to complete the entire release. A quick side note about estimates. There are a lot of techniques for creating estimates, from poker games to basing estimates on historical trends to using story points instead of hours. But no matter what technique you use, you'll want to make sure you involve at least 2 or 3 subject matter experts. There's simply no replacement for what a subject matter expert brings to the table. Keep that in mind as you do your estimates. Let's get back to this, the release backlog. With a prioritized release backlog in hand, we're now ready to plan out several sprints to get the work done. Sprints are short-duration milestones that allow teams to tackle a manageable chunk of the project and get it to a ship-ready state. Sprints generally range from a couple of days to as much as 30 days in length, depending on the product's release cycles. The shorter the product's release cycles, the shorter each sprint should be. And you'll want to have at least 4 to as many as a dozen sprints in a given release. So at this point, we can take our release backlog and split it up into several of these sprint backlogs. One of the most important things to remember about sprints is that the goal of each sprint is to get a subset of the product backlog to a ship-ready state. So at the end of each sprint, you should have a fully tested product with all the features of that sprint 100% complete. Since sprints are a very short but a realistic representation of part of the product, a late finish of a sprint is a great indicator that the project is not on schedule and something needs to be done. Therefore, it's extremely important to monitor the progress of each sprint with
An object-oriented program may be considered a collection of interacting objects. Each object is capable of sending and receiving messages and processing data. Let's consider objects of a driver, a car, and a traffic light. When the traffic light changes, it sends a virtual message to the driver. The driver receives the message, and then chooses to accelerate or decelerate, sending a virtual message to the car. When the car speed changes, it sends a virtual message back to the driver via the speedometer. The fundamental concepts of object-oriented programming include class, object, method, message passing, inheritance, abstraction, encapsulation, and polymorphism. A class defines the characteristics of an object. Characteristics include attributes, also known as fields or properties, and behaviors, also known as methods or operations. For example, a car class could have properties such as year, make, model, color, number of doors, and engine. Behaviors of the car class could include on, off, change gears, accelerate, decelerate, turn, and brake. An object is an instance of a class. For example, the object My Porsche is an instance of the car class. My Porsche has the following properties: year of 2007, make of Porsche, model of Carrera GT, color of silver. Has 2 doors, and a 5.7-liter V10 engine. A method is a behavior of an object. Within the program, a method usually affects only one particular object. In our example, all cars can accelerate, but the program only needs to make My Porsche accelerate. Message passing, or method calling, is the process where an object sends data to another object, or asks the other object to invoke a method. For example, when the object called Joe, an instance of the driver class, presses the gas pedal, he literally passes an accelerate message to object My Porsche, which, in turn, invokes My Porsche's accelerate method. Inheritance, also known as subclasses, are specialized versions of a class, which inherit attributes and behaviors from the parent class. For example, the class car might have subclasses called Porsche car, Chevy car, and Ford car. Because subclasses inherit properties and methods of the parent class, the software engineer only has to write the code for them once. A subclass can alter its inherited attributes or methods. In our example, the Porsche car class would specify that the default make is Porsche. A subclass can also include its own attributes and behaviors. We could also create a subclass of Porsche car called Porsche Carrera GT. The Porsche Carrera GT class would further specify a default model as Carrera GT, number of doors as 2, and could introduce a new method called deploy rear wing spoiler. Now, the object of My Porsche may be instantiated from the class Porsche Carrera GT instead of the class car.